Hey guys.
Hey, good morning.
All right, so let's begin. We're gonna do this a little bit different. I don't have the whiteboard with me. I had to go on a business trip, but I'm gonna use my touchpad to write things down. So for the review, let's go over, I guess, some problems. If you have any problems um, uh, that you want to go over, let me know, and we'll review them. So let's see. Yes, it's recording currently.
Professor,
Yes.
is the final going to be the same format as the midterm?
Yes, it is.
When are you sending us the questions?
I'm going to send it to you after the lecture today.
Okay.
I didn't want to send them out before the review because it doesn't make sense.
So we do have a lecture separate from the review.
Yes, yes, there'll be a lecture separate from the review. I want to go. I want to do waves. So this is kind of on my own time. So
Test then?
what's up?
So we should expect to see waves on the test then too, right?
Yes, that's correct. And then also for the extra credit, I set them due to the 23rd. I couldn't. I emailed to see when my final grades are due, and I'll set it to the day before, and then we'll just submit it by then. The extra credit is extra homework problems. So the extra homework problems are some chapters that we haven't covered, a bunch. Chapter 12, 13, and then 17 through 20. So you could pick out what you want to do, and I'll replace those with your lowest grades. And I think it's valuable because you know, in the summer course, it's not the same amount of time as a regular course, so we weren't able to cover the full semester's worth of material. And I really wanted to cover a little bit less, but in more detail. I think that's better than covering everything in less detail. So I picked out what I thought was most important. So, and then I'll also post extra credit quizzes for the chapters we missed that I didn't post the quizzes for. Namely, I think it was 7 and 8. There's two chapters right before the test I didn't give out quizzes for, 7 and 8, and then I think 9. Hold on, let me. I don't have Master in Physics up, so I don't know. Let me open it up and tell you in a second. Okay, 6 and 7, and then another quiz for chapter 9, and I'll try to post them in the next few days, and those will be due the 23rd as well. What else? Those extra credits will become available by midnight tonight. I posted quizzes for chapter 11 and 12 and 14. So for chapter 11, it's due tomorrow, and the quiz for chapter 14 is due on Sunday. I'll post after today's lecture. I'll post a quiz for chapter 15. I wanted to do the lecture first to see what material we focus on, exactly focus on, and then today or tonight I'll send out the long answers for the test. That will be due Monday. That would be due Monday. Yes, Ash, I got your labs, so don't worry. It was like 3 of them, I believe, in one email the other day. So I got them. So I also posted the solutions to test 1. I didn't get a chance to type in the grades. I want to get all the grading done by tomorrow, if possible. I've been very busy the last 2 weeks, so, or 3 weeks, so. But the solutions are up, so you can check and see how you did. Any other questions for admin? Okay. Tell me what materials you want to cover, and we'll cover it. The test will cover. Let me see. The test will cover everything from the first test, everything after the first test. So, chapter 8 and beyond, right?
So it's not a cumulative test?
No, it's not a cumulative test. It'll just be for the second part. So.
Can you tell us all the chapters that's going to be?
Yes, yes, I can tell you exactly what chapters. So. Let me pull it up. So it'd be from chapter 8, chapter 9, chapter 10, chapter 11, and then chapter 14 and 15.
And it's going to be the same format as the last test, or is it going to change?
Same format.
All right.
Two long answer questions. That would be due Monday night by 12, and then the short answer test consisting of about 10 problems, and then you'll get about an hour and 10 minutes. I have to finalize it to see how long it'll take. And then
that's on Tuesday, right?
What?
That's on Tuesday.
Tuesday. Yeah, that's correct. During class time, and then the oral part, which would be the same format. So when you review for the orals, just think about what questions that you can expand the problem on. You know, what other concepts can this problem be tied to? You know, and try to think creatively. You know, like, okay, let's see how far we could take this problem, and you have to know the problem inside and out. You know, the questions inside and out. So, you know, be very similar to the first test, the way I asked the questions, and they'll be more conceptual, right? You know, more thorough problems. You know, keep you on your toes. Any other? Did you guys like the oral questions? You thought they were fair and all that?
Yeah.
Okay. Good. So you have to give me problems to go over. Otherwise, I don't know what problems you want to go over. So. Okay. Anybody else have any problem? Well, somebody's in the chat room. If you have any problems to go over, that's what I'll go over. Otherwise, we could just meet during class time. Anybody else have any specifics that you want to go over? I'll give you a few minutes. If you're looking for something, just tell me, hold on, I'm looking for it. So I know. Now is the time, guys. Any homework problems you want to go over? Any quiz problems? Anything you've seen in the book? Any material, section 8.2? Anybody? Now's the time.
The lecture would be at 11:30, right?
Yes, or 11:40. 11:40.
Copy. All right, thank you, Professor.
Yeah, no problem. I'll see you then.
Yeah.
Anybody else? Anything? Helen, Jeffrey, Jediah? Yes. Okay, we gotta take her. All right. Hey, Minoru, what question? What quiz is? Do you know what quiz that's from? What horsepower? Chapter 8. Okay. Just give me a second. Let me pull it up. Okay, guys. You can see my screen, correct? Okay, so in this problem, can you see my full screen or do you just see the whiteboard? can you see my other part of my screen? Or just the white screen? Okay. So let me show you the problem, and it'll have let me show you the. Okay. So this is the problem that Minoru was talking about, right? So this one has the solution on it and everything, but I'll go into a bit more detail. So a driver notices that her car, her whatever mess car, slows down from 98 kilometers per hour to 62 kilometers per hour in about 6.5 seconds when it's just in neutral. So it's just coasting. There's no power supplied by the engine, right? And it's asking what power is needed to keep the car traveling at a constant speed of 80 kilometers per hour, right? Now, in this problem, we assume that the losses due to air drag and whatever slowing the car down is constant from 98 kilometers an hour to 62 kilometers per hour, right? We assume that this force is constant, right? Now, now the power that we need to supply to the car to keep it moving at that speed at 80 kilometers per hour is just going to be the energy loss in that given time frame divided by per second, right? That's what power is. It is how much energy is expended in a given amount of time, right? In this case, we set it to 1 second. Now, now, if we keep it traveling constant at 80 kilometers per hour, that means that the kinetic energy is constant. The kinetic energy does not change. So whatever power is lost through frictional forces or drag or air drag, that's going to have to equal whatever power we supply to the car. So we just have to calculate the average power lost during this time interval, right? So what we do is pretty simple. You can see it over here. We calculate the power, the average power lost in this by calculating the loss in kinetic energy. We don't consider any potential energy because it's on flat ground, right? So let me pull up that whiteboard. So first, obviously, we have to, of course, we have to convert kilometers per hour into meters per second, right? So if we take 98 kilometers per hour and we want to convert it, right? So we'll do this, right? So we want hours over seconds, and then it would be 30. So there's 3,600 seconds in an hour. Right. And we convert it into meters, kilometers into meters. So that should be 1 over 3,600 and 1,000 kilometers per meter. And then we'll get, let me just do the calculation real quick. Let me just, 1,000 meters in 1 kilometer. So 98 divided by that. So it comes out to 27.2 meters per second. All right. And you do this for the other part of it. And if I'm sorry, for the other for the final velocity 62, and then you'll plug this into let me calculate that. So 62 is 17. So 62 is equal to 17.2 meters per second. Right. Now, let me clear it. Now, we'll just calculate the power. Power is the average power lost in this time, right? You got to realize that the power loss, the instantaneous power loss is different, right? Because the instantaneous power is different at each time interval because the speed that which we're going is different. So even if the air drag is the same for each interval, the amount of distance that we travel is different because we're going at a different velocity. But we're assuming that the loss is some constant, the work done by these frictional forces is some kind of constant across the whole loss in speed. So we do this, and it's just well, it's the change in energy, right? So then we would just get this V final, and we could just do this V initial over time. And then we find the average power lost. This is the average power lost is equal to, we plug it in. I'll just copy the answer from the solution so I don't have to plug it in. Is equal to 4.2 times 10 to the 14 watts. So this is the average power lost. Our car is going to have to supply the same amount. So this will be your final answer. Is this, right? To keep it going at the constant speed, its kinetic energy can't change. There's no potential energy that it's transferring it to. So whatever is lost in the kinetic energy is the total energy lost, and this is what's supplied by the car. So it's not too bad. There's a lot of little things that you need to recognize, that there's no potential energy, you know, that, you know, the car has to supply the same amount of power as what's lost, and you have to make this assumption that the power lost across the whole time that it's accelerating is constant. You assume that, and it's a fair assumption, or not even constant. It could be linear. So they chose 80 kilometers for a reason, right? That's the midway point between 98 and 62 kilometers an hour. So if you had that linear function, so if you have a linear function, if you remember how we did that, so if we had a linear function, right? Let's say this is let's say this is the kinetic energy, or let's draw it the other way. So let's say this is the kinetic energy over time, and it drops down, right? From 98, this is 90, this point is, let me get my spotlight. This point is 98 miles an hour, and this is 62 over here. 80 is the midway point. So if we take the average of if we just take the average of these 2 points, right? And since this is linear, the average of these 2 points will correspond to the midpoint, right? So they chose 80 kilometers for that reason. So if you assume that even if it's not constant, it's linear, it still works properly. I'm not sure if this I want to test this out in class, for class. Hold on a sec. I'm not sure how it records. Okay, let's try this one, and then I'll write like this. I hope it doesn't just record my video. Okay. Let's see how this records. Okay. All right. This is a good test. All right. So any questions on that problem? Okay. What other problems do you guys want to go over? Anything else? I wouldn't say it would be a major part. I mean, it's important. I mean, it might be a problem with or two. I don't think it's a major part. Usually the center of mass problems, it's a tool more so than anything else. So you will have it would be incorporated into your other problems. Maybe there'll be a short answer problem on calculating center of mass, but we didn't go over the integral form of it. I left that out. and that would be the more challenging aspect. I would just have the so the center of mass is important for moment of inertia. So if you're calculating the moment of inertia, you kind of use the center of mass. So I wouldn't say it's a major part, no. It's my short answer to that, but you should know how to do it. Anything else, guys? Going once, going twice. Give you a few more seconds. That's it. Then we'll wrap this up and then we'll just do the lecture. Okay. Is this from the homework or? All right, hold on, let me pull it up. Okay, so let me let me share my screen again. All right, so in this problem, a rocket is fired in deep space where gravity is negligible. So there's no gravity. It's just, we'll just consider the system of the gas and the rocket as in this problem. in the first second, it ejects 1/160th of its mass as as exhaust gas, right? And has an acceleration of 15 meters per second, right? And then in the X, what's the speed of this exhaust gas relative to the rocket? All right, so we're gonna make some simplifying assumptions here, right? We're gonna assume, since it's releasing 1/160th, 1/160th of a mass, we could assume, and that's less than 1% of its mass. So we'll assume that the mass of the rocket does not change. Now, these problems become more complicated because here the mass of the rocket can change, but let's assume that it does not change, right? Now, hold on a sec. Hold on. Just give me a second. I need to let me look it up for a sec. I need a second to look it up.